Start. Hello, my name is Samuel Kasai, and today I'll be talking to you about the U Substitution Rule. The U Substitution Rule states if U equals g of x and is a differentiable function whose range is in a given interval, and f is also continuous on that interval, then the integral of f of g of x, g prime of x dx can be written out in this way, which is the integral of f of u of x of u du. Essentially, what this is stating is if you don't know how to integrate a function just by looking at it, or because you know the derivative of it and you can work your way back from that, the way you can use the U substitution rule is by first acknowledging that there is a function and its derivative within that integral. And once you've identified that, then you can separate the function outside of the integral, take the derivative, and replace that with a u. So let's go into some examples. The example we're going to be doing is the integral of x sine of x squared dx. As I've stated, if you have a function and that derivative of the derivative of that function is within the integral, which it is in this case, we have x squared and we have x, which x squared makes x. Once you take the derivative, we can do the u substitution. So initially, what we do with the u substitution is we write our u outside and make it equal to the function that has the derivative inside, which is x squared in this case. And once we do that, we take the derivative of du of u and of course x squared, which gives us du equals 2x dx. And with this, we want to replace all the x's in this integral with the u's. To do that, we move the 2 here and to the other side, and so we get 1/2 du equals x dx. The x dx cancel out in this equation and are replaced with 1/2 du. But since 1/2 is just a constant, we can always move outside the integral. So we write a new equation, or a new integral, with the 1/2 outside, and instead of the x squared, we have a u that we replace x squared in here. So we get sine of u du. So now we can easily take the integral of this, which equals the derivative of this, becomes negative cosine of u. And then bring the 1/2 back to the front. But we're not done yet, since we have to still replace the u with its original function, which then this whole thing becomes negative cosine, 1/2 negative cosine of x squared. And that is the antiderivative of the original function, or the original integral, x sine of x squared dx. So now, moving on to a more interesting example, the integral of sine 2x over 1 plus cosine squared of x dx. This incorporates a trig identity and also 2 u substitutions. That's what makes it more interesting than the previous example. To do this, first we rewrite this integral using a trig identity, which I have written out over there, as the integral of sine 2 sine of x cosine of x all over 1 plus cosine squared of x dx. From here, we do a u substitution. To do that, we make u equal to cosine of x. And then once we take the derivative of this, we get du is equal to negative sine of x dx. So now we move the negative onto the other side. So negative du is equal to sine x dx. Now everything replaces, and we get a new integral that looks something like this. Negative 2 u replaces the cosine. The sine is replaced by the du. So this whole thing becomes just u. The 2 goes outside just because it's a constant. Over 1, and this is cosine squared, so it's u squared. 1 plus u squared du. From this point, we have to do another u substitution, or another substitution, which could be, now you just have to choose a new character, because you've already used the u. It could be anything, as long as you don't get it confused. I'm just going to go with s. I'm going to make s equal to 1 plus u squared, since the derivative of this is incorporated within the integral. So now ds is equal to 2u du. Move the 2 to the other side. 1/2 ds is equal to u du. Now these get replaced, the u and the du, with 1/2 ds, and this is replaced by the s. So now we get another integral that looks like this. And also the 1/2 over here cancels out the 2 over here, so we're just left with a negative. Negative of the integral 1 over s ds. And from this point onwards, we can find the antiderivative of this fairly easily, which just becomes ln of x, or ln of s. So it becomes negative ln of s, but since we substituted the s with 1 plus u squared, we do that again. We replace the s with 1 plus u squared, and then from this we replace the u again with its original value, which was cosine of x, and since it's squared, it becomes ln, negative ln of 1 plus cosine squared of x, and that gives us our final value, which is the antiderivative of the integral sine 2x over 1 plus cosine 2x dx. That's our answer. That's how you use the u substitution. Thank you for watching. Have a nice day.